A gas is taken through cycle abca, okay, shown in the PV diagram below. PV is pressure and volume. The net work done is that, blah, 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 internal energy, etc., etc. Okay, so this is a thermodynamic cycle problem. And the first thing I usually do with these problems is I write out the first law of thermodynamics. And though it looks pretty simple, and I guess it is fairly simple, there's some nuance that you should be aware of. So what this says is the change in internal energy of a gas is going to be the heat added to the gas minus the work, W, work done by the gas. Done by gas. Now, one of the complicated things is in chemistry, they write this as a plus Q plus W, and it's work done on the gas. Doesn't matter which way you think about it. This is the convention in physics. Chemistry is a little bit different. Just get one convention and go with it. So delta U is change in internal energy. Q is heat, energy in the form of heat added to the gas. And W is work done by the gas. All right, so now that we got the formula written, I write out a table, and I do it as such. So we do A to B, B to C, C to A, and then we're just going to do the total. There we go. Oh, and I'm going to draw some grid lines. Hop, like so. That way we can plug in the values. All right, so now we're going to go back to the problem again, and we're basically going, I kind of glossed over once I saw where this was going, glossed over some of the numbers. So now we're going to pay attention to the numbers. So net work done is 1.2 joules. Okay, so work total, net and total are the same concept here. It's going to be 1.2 joules. I'm going to just kind of assume, which is always dangerous, that when they say network, they're using the same convention that I am. So this is physics. This is the physics convention. We're going to go with it. Along path AB, right here, A to B, the change in internal energy is 3, specifically plus 3. And the magnitude of the work done is 5. So this is 5, but they don't tell us positive or negative. So what I'm going to do here, because they say magnitude, is I'm going to look at a definition of work. So one definition you might know is work equals integral f dx. Or if you don't, so when you have a constant force, then you can pull out the f and you get integral dx, which becomes f change in x. Well, pressure equals force divided by area. Here you can say force equals pressure times area. Long story short, you replace the f here, and you also get work equals integral pdv, sorry. Pressure times a differential of volume. When pressure is constant, you have the formula pressure delta V. So if we're looking from A to B here, and we have pressure delta V, well, the pressure going from left to right here is constant. So, and it's positive because it's above the x-axis. And delta V goes from smaller to bigger. And we go from smaller to bigger, the change is going to be positive. So positive times positive is a positive. So this 5 right here, even though they're ambiguous about the sign because they said magnitude, we know it's going to be positive. All right. Along path CA, C to A, energy is transferred to the gas as heat. So this is Q added to the gas. They're telling us a number that's added to the gas as heat, and they give us a number of 2.5. So this is going to be 2.5. If they said something like energy transferred from the gas, then we just have to take the negative here. But since we're talking about the same thing here, Q added, heat added to the gas, and they give us a number, we're just going to take that number, plug it right into our table. how much energy is transferred as heat along path AB and path BC. Okay, so we're looking for change colors just to kind of add emphasis. No, that's a terrible emphasis. Green. Gray. This value and this value, AB and BC. All right, so for this top part, actually I'm going to fill in some things that we know first. So it's a cycle, so the change in internal energy is going to be 0. The whole idea of a cycle is it starts back at the beginning. And so the total change in internal energy has to be 0. We have the formula work equals pressure times change in volume. So there's going to be no change in volume, i.e. from C to A. We know that that's going to be 0, so I'm just going to put this in as 0 real quick. It's kind of nice to get the zeros in there. That way you can focus on other things as you go. All right. First question is Q added from A to B. So we know that this is the value we're looking for. So 3 equals Q added from B to C. No, A to B. A to B minus 5. So this is the equation we get just from this top row right there. And so solving this, we get Q, I guess call this Q A to B, equals 3 plus 5, which is 8. I know it seems easy, but it's so easy to get the signs mixed up that it's worth going through all the details here. I know, you might be like, I'm so tired. I know, I understand. All right, so now what we're going to do is we want to find B to C. So the easiest way to find this is we can use this bottom part right here. So we know that 0, I'm going to do it up here. I know, my work is messy, and I apologize. 0 equals Q total. So Q total minus 1.2 equals 0. Therefore, Q total equals 1.2. 1.2 plus minus 1.2 equals 0. I gotta check that real quick, make sure I got the number right. The net work done is 1.2. Yep. So, and then specifically when it says net work done, that means net work done by the gas. All right. So now I got 1.2 right there. So now we know, I'm going to erase these real quick. Whoop. We know that we can add up all of these. Sort of. You'll see what I mean. So QAB plus, I know my notation changes like every time I write it. That's so terrible. QCA equals Q total. And so, if we're looking for QBC right here, QBC is going to be Q total minus QAB minus QCA, which is Q total, which is 1.2, minus QAB, which is 8, minus QCA, which is 2.5. So I'm going to rewrite this a little bit. So this is 1.2 minus, I don't know, is it 10.5? I'll say 10.5. Go over here, sidebar. 10.5 minus 1.2. We got a 3. We got a 9. Oh, I'm going to do that. So carry the 1. There we go. 10 minus 1 is 9. 9.3. Yeah, I'm good with that. And we know it's going to be negative. So negative 9.3. And so the value here for part A would be 8. And it'd be 8 joules because everything is energy measured in joules. And B is going to be negative 9.3 joules, meaning that from B to C, it's the heat, negative heat is added to the cycle, meaning that heat is actually flowing out of the cycle. So that's how I'd approach this problem. Hope it helped. See you next time.